So problem 2, we've got a couple buying a house who's borrowing $265,000 for 30 years. So $265,000 is what's borrowed for 30 years at 7.6% interest, 0.076. And it is going to be compounded monthly. So let's do our R over M, 0.076 over 12. I'm not sure if that's going to come out even. Does not come out even. I need to leave it as a fraction. So MT is 12 times 30, 360. And so what we've got is our borrowed amount, $265,000, is equal to R times 1 minus 1 plus 0.076 over 12 to the power of negative 360 over 0.076 over 12. What a nasty problem. Thank goodness for Wolfram. So we have 265,000. Know what R is, and the I is going to be 0.076 over 12. That's 360. 0.076 over 12. We need to divide, of course. 141, 628. We get $1,871.10. So the monthly payment for this house is going to be $1,871.10. So how much are they going to pay in interest? And so for part A, the monthly payment is $1,871.10. To figure out how much they're going to pay in interest, we need the total payoff, and the total payoff is going to be the monthly payment times 12 months in a year times 30 years. They're totally, gee, many Christmas. They're going to pay back $673,596. Let me make sure I did that math correctly. Looks like I did. What a terrible deal. So total payoff is $673,596. Wow, they're going to pay for their house like at least 2.5 times. That's pretty crazy. So how much of this is an interest? And so if we take those and subtract them, we would subtract 673, 596 minus 265. And they're going to pay $408,000 in interest. So total interest is $408,596. What a terrible deal. So continuing with number 2 there, the couple were to pay an additional $200 toward the home each month. How much sooner would their house be paid off? And how much money would this save them? So got another problem to go here, SERM 10. And so they're paying $200 more toward the payment each month. And so that would be a payment of $2,000 $71.10. The rate would still be the same, 7.6%. Still 12 months in a year. We don't know how long it's going to take them. We know they're borrowing $265,000. So 0.076 over 12 is my I, and MT is going to be 12T. So my formula: we got $265,000 is equal to 2,071.10 times 1 plus 0.076 over 12 to the power of 12t minus 1 over 0.076 over 12. I can't imagine doing that problem by hand. That would be just terrible. So we've got 265,000 as our S. Our new monthly payment is $20.71.10. Our I is 0.076 over 12. Our N is 12T. We don't know how long the loan is going to be now that we're doing this. 0.076 over 12 again. Well, that would significantly shorten their period of their loan. They would take about 8 years off the loan. So the T is going to be 21.9458. And so C, paying $200 more per month, gets their house paid off about 8 years sooner. And how much would this save the couple in interest? And so for Part D, we need to get the total payoff of this option. So the payment is $2,071.10 times 12 payments in a year times 21.9458 years. So 2071. Sorry about that. Had a phone call. So 2071.10 times 12 times 21.9458 gets us 545,423 and 36 cents. So 545 is considerably less than 673, which is what their total payoff was going to be. So total payoff with this option is 545, 423.36. And so how much money and interest would doing this save the couple? We can just simply subtract the 673, 596. Which is the initial total payoff up here, from and subtract the 545, 423, 36. So 673, 596 minus 545, 423, 36 gives us $128,000 or so. 128, 172, 64. So doing this saves the couple about $128,000 in interest. And that's not too shabby.